All right. Here we go. Exponent rules. Exponent rules and simplifying radicals. That's what we're going to look at today. Exponents. What are exponents? What is it? What's it for? Well, exponents are used to express repeated multiplication. Of the same number. For example, if I want to multiply a bunch of 2's together, this is only 4, it's not that bad. But what if there was 400 of these? I don't want to have to write 400 2's. Same thing, 2 times 2 times. I don't want to write that 400 times. So a symbol was created to represent repeated multiplication of the same number. It's called the exponent. This is called the base number. So the base number is 2. That's the number that's being multiplied repeatedly. And then how many times it's being multiplied is what's called the exponent. And it's a little tiny number in the top corner of this number. So this means 2 to the 4th power, and it means 2 multiplied 4 times. So in general, I have a base number. I have an exponent. This right here is called the base number. This up here is not a number, it is an exponent. And it basically means b times b times b repeatedly in times. That's what exponents mean. So we can develop some rules based off of this definition that can make simplification of these exponent stuff easier. I'm going to give it to you in a certain order that if you follow the rules in this order, you will be done within 5 steps, no matter what kind of problem is given to you. It does not mean you have to do them in this order. Sometimes as you get more experience, you'll see that I can do things a little bit differently and be done even faster. That comes with experience. If you're just learning this and it's new to you and you're not sure, just follow the order in which I'm giving it to you. Be done, guaranteed, within 5 steps. Okay? So the first thing I'm going to do in my exponent rules, the first rule I always look for is I look for the 0 exponent. A 0 exponent basically says if I have a base number to the 0 power, that is equal to 1 by definition. And the base number cannot be 0. So 0 to the 0 is not 1. Okay? It's undefined. So I'll look at all my work, my problem that I need to simplify, and if I see any 0 exponents, I just turn those things into 1s, and there that's helps me simplify it out. The next one that comes up, this is the first one. The next one that comes up is 3 and 1. I call these the power rules. There are 3 of them, and they're all in this one rule. So if I see these rules, any one of these 3, I do them at the exact same moment. Okay? And they are this one, which is a power raised to a power. So base number to a power raised to another power, like that. And this one, you multiply these exponents together. This one, I have 2 different base numbers multiplied together, yet raised to the same power, like that. Then I can take each of these numbers to that exponent. So that'd be a to the m times b to the n, just like so. The third one is a combination of, like the division one of this one. What if I'm dividing instead of multiplying? Well, that just means one of these was a fraction, that's all it means. Then it's just just like that. So if I have anything like with parentheses like this, power raised to a power or something like this, I'll do all three of these at the exact same moment. We'll do some examples in a little bit, but that's what those are. After that, I do the product rule. The product rule basically says this: if I have two numbers of the same base, different exponents, they have to be the same base. They can't be different bases. They have to be the same base. Then I can just continue this out, and I get, and you add these exponents together. The fourth one is the quotient rule. And product quotient means divide. What do I do if I'm dividing? What if I have the base numbers are the same, but it's in a division process like this? This is the letter N, this is the letter M. Then you need to subtract the exponents. The top one minus the bottom one. You have to remember that it's the top exponent minus the bottom exponent. And because of that, you may have a negative exponent. Like so. What if there's a negative exponent? The negative exponent, the negative portion, just changes the position of the base number with its exponent. So it's literally a reciprocal action. 1 over b to the n. Notice now that it's on the bottom, the exponent is now the opposite sign of what it was. Because I can do it the other way too. What if I have a negative exponent on the bottom? Well, then this whole quantity can move to the top of the fraction and just becomes b to the positive n. So these are my exponent rules. So let's look at a really quick example to show you how these are all kind of done. Okay. I won't use every rule in this example. I'll just give you a ballpark of what it is. So let's say I have x to the third, y to the negative 2. We'll raise that to the negative 2 power. On the bottom, we'll have x to the negative 5, y to the 3, and we'll just leave it like that. So if I want to simplify this, the first thing I would do is I would look to see whether or not there's a zero exponent, which there is not. Then I will look for things that are in parentheses, which I have right here. So you can see that this is a combination of a power raised to a power and this one where they are being two different base numbers are being multiplied together. So how this works is this exponent will drop on each of these and multiply to each of those exponents there. So on top, you'll end up with x to the 3 times the negative 2 and a y negative 2 times negative 2, like that. On the bottom, it stays the same. We have this and we have this. The next part is product rule. Do I have anything multiplying that have the same base? Well, these are not the same base, so this product rule does not apply to these two. This is an x, this is a y. These are not the same base, so the product rule does not apply. But if I go to the quotient rule, this is a division. Those x's match that quotient rule, don't they? So then I can do the quotient rule with the x's, and then I can do the quotient rule with the y's. So this becomes x to the negative 6 minus a negative 5. And I strongly recommend you write it like that to make sure you get your signs right. And this will be y to the 4 minus 3. To make sure I don't make a sign error, do you notice I'm putting the second one, the bottom exponent, I'm putting into parentheses so I don't make sign errors, just to get used to this, which is where the most common mistake is made. A -6 minus a -5 is a -1. Y, so 4 minus 3 is a +1. This is the only one that has a negative exponent. So it is the only one affected by the negative exponent rule. The y will stay where it is, which is on top of a fraction. And so this will become something like that. And I'll get y, which is on top. This drops to the bottom, and the exponent becomes positive. And that's my final answer right there. Exponent rules. We'll do more examples of this, but we'll do it outside of the video.